Hello, I'm just going to do a little introduction here into some of the changes which have happened in LightWave. Now, this is a bit late, I know, but people are still struggling with some of this stuff, so I thought I'd do some explanations, at least from my perspective, how I understand it works visually and in a technical sense. So this is a basic scene, what we have in this scene setup. I'll just show you I'll turn on VPR so you can see. What we'll have is an area light on this side and a luminous polygon. Now, in terms of the housekeeping, I have the area light is set to 100% intensity with an inverse distance squared fall off and a nominal range of 1 meter, and that's important. I'll go into that in a minute. And in terms of this luminous polygon, this is set at a luminosity of 314%. Now, this figure will become interesting later on, but just sort of showing you this. The default, I think that's not being used currently. You've got ground and the sphere. These two materials here are what's in the main scene, and as you can see, I have in the render settings 4 shading samples, 4 light samples, just to get a bit of smoothness, 16 rays per evaluation, and no interpolated. This is just to give the best sort of comparison between the render engines, and as you can see, it's 2015.3, which is the last version of the old style of rendering. So that looks pretty clean. It's not especially fast, not especially slow. I'll change that perspective. You can tumble around that. It's a little bit noisy, but you would expect that because it's got radiosity. And as you can see, what's interesting about this is that the approximate amount of light on that side is about the same as the amount of light on that side with radiosity. Obviously, if I turn off radiosity, that doesn't do anything. Now, you're sort of thinking, well, why is it that 314 on this side is the same as 100%? Well, it's very simple. If I quickly switch back to the textured shaded view and look at the light, you see the old system, the way that it worked was you've got a light, that's your emitter, but the nominal range as set up in its properties is 1 meter. So it's actually 100% bright there. And with inverse squared fall off, as you can see, the further it gets away from the light, the less intense it gets, but more importantly, the closer to the light, the more intense it gets. And as it turns out, approximately, this value is actually pi on the surface of the light. So when you look at it in VPR, it's actually much higher than 100%, but what you will notice is where it touches the floor, you get a lot of noise because it's not very good at doing this sort of really close to an object. Meanwhile, radiosity, albeit it's quite noisy, you do get beautiful smooth transition, and there's no problem. Now, the next thing to note here is I'm going to just compare specular and reflection, and this is where the biggest change happens. So I'll just get back to our camera view just to sort of, because this is a much better evenly measured difference between the pair of them. So go to my sphere surface and make the specularity, well, I'll make that 4% and reflection 4%. Now what I'll do is I'll go into the advanced tab and make the let's see, oh no, it's in the environment tab, it's been a while since I've used this, reflection blurring to be 10%. So that's going to smear the reflection. I'll make it 5% just to make it a bit clearer. And what you'll notice is for the same intensity of light that the reflection shows rather lovely here, and there's pretty much no specular. Well, there is. What you need to do is turn the diffuse off, and there it is. Oh, it disappeared. It's there, it's just almost invisible because Specular is way too weak in this version of LightWave, which is why the big change happened. So what I can do is I could make that, say, 400%. Still a little bit weak and very noisy. Bearing in mind I do have 4 samples in the shader, so I could make it maybe, I don't know, 1000%. That's similar, but as you can see, you're starting to pump. Now, of course, if you change the lighting, this is a very simple scene. If I change the lighting and put a closer light or a distant light, that would rapidly break. You would get insane speculars if I put a distant light, and like say if I put in, let's see, items, lights, distant, and rotate it. You can see that's getting a really bright hot spot, but that's almost invisible. It's not really very much use. So I'll just clear that from the scene. So that's sort of showing the main problem we have here. Also, as an interesting point, there is no Fresnel function. Now I can do this using the node editor, which some of you will have already done. So I'll just put this back down to 4% because that's the correct value. Now if I take a Fresnel, standard one, the DP kit one has a little bit more power, but you know, that this one's just the basic one that comes with LightWave, a Fresnel function of 1.5. Plug that into my specular, my reflection, and my inverse into diffuse. So there you will see it balances the two. So as it gets closer to the rim, you start to get more reflection. As you can just see, that's picking up a little bit at the leading edge there. But on this side, obviously, it's way too dark because it's reflecting with the specular. There's nothing to reflect, so you get this kind of dark limb, which is the downside of doing that. And it looks fairly, it looks fairly good, but it's not great. If I copy that material and put that onto the ground, and you can see that's working rather nice. So you've got this lovely reflection of this very bright object. You can see the reflection of the reflection is occurring here, as it is here. But again, there's just almost no specular. It'll be there, it's just very, very dim in this balanced sort of scene. So that just gives you a rough idea of how that's happening in 2015 and why you often get weird results. I've noticed this for years. So I will save all, go to that scene, and I'm going to open that up in LightWave 2018. So quickly drag that into there, ignore this warning. I'm not going to save it, it's not important. So first thing you'll notice is that the lighting looks very similar in OpenGL because it's it's not that much different. And I will hit VPR. And the first thing you will notice is obviously that while the specular on the ground doesn't exactly match, those two look very similar. So you have a very, very hot thing happening here, and I will just take this back down to naught. Oops. Just so that you're getting like for like again, because there was no roughness, I think, in the oh yes, there's no reflection blur, of course, in standard. Right, that's why it was. Right, now first thing I'm going to notice here is on the import, this is blowing out and it's wrong, and the reason for that is, and I'm not sure why this happens, it's part of the import feature, is that intensity is off and it's on in the node editor instead, but this can produce very noisy results, so just delete that and turn the intensity to inverse squared, and this now looks correct, and you will notice immediately that within a few samples that is incredibly clean. This is obviously noisier because it's brute force radiosity, but it doesn't take an awful lot of time to clean. So what you'll see here is, if you'll see this side and this side now are at the same intensity, you can see on the light it's now 3.14, and what it's done is it's worked out that because it was 100% at 1, which is the standard nominal range, it'll be 3.14 on the surface area. We can also of course make this visible to camera, so it looks pretty much exactly the same on both sides, and you know, that's looking pretty spot on. So we'll go into our surface and we'll make the modifications again. So I'll go into the sphere. I will, well, we have no reflection blur, so I'll just have to make it as maximum. So I'll take the specular, make it 4%, and I'll go to the reflection and make that 4%. Because that's a very high value, 90, it looks pretty much exactly the same with a few minor differences. Now what I'm going to do is show you. Now you can set this up with a Fresnel, of course, as you could before. So you would plug that into specular and reflection, and the reverse into diffuse, and that's now showing you a lovely Fresnel fall off. And I'll copy that to the ground, and you will notice that these two now almost identically match, apart from the fact that because of the changes in the engine I can't make this blurry, so it's just a matte reflection, but it's exactly the same on both sides with a few, you know, tiny differences, but that, you know, that sort of shows you the rough comparison. Now this is where 2018 comes into its own. This material's not great. I can do a better one, and that's called the principled BSDF material. So I'll go into that. I will change that to principled. I will make the intensity of that match the same, which was 200. Oh, and there we go, 200. Specular is at 50. Which means it has approximately the same Fresnel function as 1.5. And the other thing you will notice is, because it's been added, I'm just going to change that to be Glossy Reflections, so that now that's showing a reflection. So you've got ray tracing plus backdrop because it's reflecting the environment. I haven't got a background, so it's just showing black. So automatically you will see this material has just the basic values, 10% roughness, which makes it a little bit soft. It has 50% specular, which I will show you in the specular buffer. So Specular Direct, that is the reflection on the ground and on the floor, slightly rough, and the Specular Indirect is the reflection of the environment. And because we don't have indirect specular enabled on the ground floor, what I'll do is I'll quickly just go copy and paste, and there we go. That's working exactly as we would expect it to. It's slightly blurry on the floor with a nice sort of fall off bit bigger as it goes further away, and we'll go back to the final render, and that's looking pretty much exactly the same, albeit a bit noisier, and it has to clean it up a little bit. So I hope that helps to clarify some of the issues between the differences between the two, and why we have this material. It has a built-in Fresnel, it has perfectly balanced in terms of the lighting, and the specular is actually spot on in terms of matching a reflecting environment, which of course it should, because specular is just reflection. That's the difference between the two. Specular and reflection are basically two sides of the same coin. It's just one of them involves using a light and one of them involves using just the environment around itself. Now, one thing I'm going to show you, I'll just turn off VPR on here and go back to this material, on here in 2015. Now, one thing I will show you is if I increase or decrease the glossiness, which is the same thing as increasing the roughness, to 50%, and go to the environment and change the reflection blurring to 52. Well, that is quite spread out. I'll copy that to the ground, paste, and that's quite soft. And what you will notice is, I mean, I haven't got the Fresnel on here, but you can get the idea, is it's not that blurry. It doesn't do an awful lot. It sort of smears it a bit. If I make the diffuse note in here, do the same thing with that, it looks quite nice. But the specular, I can't get these to match. Look, that's 50% blurry and that's 50% glossiness. They don't look anything alike. If I make that, what was it, about 1000 again? No, it doesn't really balance. So that it roughly matched before, but that's far too much. And it sort of does this weird sort of fall off where it just sort of goes so far and then just stops like that. Yeah, it's not that great. It looks a bit better on the floor, but on this one here, that doesn't look great. So I'll just turn that back off, just to make it a little bit faster in 2018. So I'll go back to here and I will go to these surfaces and make it 50% rough. Ground, do the same there. Now it takes a little bit of time to clear up, but you have this very nicely soft spread blur. It almost looks the same on both sides. Yep, so just let that clean up a bit. If I show you the Specular Indirect buffer, I'll do the Specular Direct actually. You can actually see how pleasant that looks. Has a much bigger bleed off, and as I said earlier, because you've got these important sampled lights, you get this beautiful clean specular fall off here. And again, show you the Specular Indirect. Again, a bit noisier. I'll just check the render properties, what we set on. Oh, it's only set on 1. I'll change that to 4. That should make it a little bit cleaner. And you get this much nicer soft specular, and you'll notice how broad it can go. It goes all the way up to here instead of just this sort of hard bit in the middle and then suddenly falls off. It's a very soft bleed off. Obviously that does in fact have a render cost, which some of you will have noticed, but it is a far more attractive looking specular fall off than the old version, which was based on Blinn, I believe. This one is based on the generalized Trowbridge Wright, or GTR, or GTX, depending on which version you're talking about. But I think ours is based on GTR. And you are getting some beautiful soft speculars here, albeit a little bit slow to render. And hopefully that explains the difference between them and why sometimes this looks pretty noisy in comparison to the old version, because you're just getting a much softer version. You'll notice as well in the surface editor for this there is no diffuse input because it's not needed, and there is no reflection because again it's not needed. Specular handles both and they mirror each other, and if you see them together, the total result of that together, obviously I can't show you a combined result using the buffers, but specular direct, specular indirect, diffuse indirect all add up together to make this sort of lovely soft material. What I can also show you as well is if I quickly turn on a background environment. So I'll just use the standard background here, and just to give you something a bit more interesting to look at than black, and I could hide, we'll just go to the Specular Indirect. Oops, that's the wrong buffer, that would help, not help at all. Specular Direct, oh no, the Specular Indirect. So that's reflecting the environment. Now you'll notice as well, something else that has to be noted about the specular is it has a Fresnel function, but important distinction here is as you increase the roughness, the Fresnel function falls off, and this is what's called microfacet theory. So I'll just show you, because the picture's 1,000 words and a load of nonsense me talking, it doesn't help a lot. So if I decrease the roughness, you'll notice as well as being crisper, the edge effect much increases, and likewise if I go to the diffuse indirect, you can see a slight amount of limb darkening, and then if I increase the roughness, I'll change it back to 50 just as a comparison, because it's what we're using before, the limb darkening drops. It's difficult to see on here, but just the combined result works. And I go to the Specular Indirect again. Oops, that's the wrong one. I keep hitting the wrong one. Specular Indirect, and you see the limb darkening. The limb gets much shallower. Same thing will happen with the ground. So I can decrease that, and it gets much brighter and more like a mirror. And then as I increase it, the reflectivity of it, because on the glancing angle, because we're seeing this on a glancing edge, gets much dimmer. But conversely, I'll go to the diffuse indirect here. If I decrease that, it gets darker. It's subtler to see on the diffuse, and as I increase it, the diffuse is getting brighter, which compensates for the reflection. So this is basically, the whole thing works in an energy conserving way, and this is works perfectly, very artist friendly, and doesn't require you to have a million nodes, because I will point out, even though that node is there, the old material still exists. I have no nodes. This is just me controlling a slider, putting an artistic value in. I don't need to plug anything in, it all works together. Alright, hopefully that helps to clean up some the issues you're having. Hopefully I'll be doing a video shortly again, going into how to do texture sets and energy conserving materials using the principle BSDF. Alright, cheers guys, thank you.